Hi, how's it going?
Good. Uh, how about you?
Doing pretty well here. Before we get started, can you tell me a little bit about your background?
Senior machine learning engineer, speech to text, risk assessment of user profiles, and deep reinforcement learning.
Yeah, thanks for telling me about that. I don't have much of a background in machine learning, so I'm not sure if I can help you there. Can you tell me a little bit about your motivation for joining Interview Kickstart and what you think of the program so far?
Yeah, so I've read that in applying to big tech companies like Google or the Faang level companies, you need to really um uh, prepare really hard. I mean, from the coding to the systems design and also the domain specific portion. I think that Interview Kickstart has all those compared to other services. Also, I'm a full time employee, so having a program like this that I follow, it's gonna be much more convenient for me. And also with the with the mock interviews, I got to practice my how I explain things and how I come across in interviews.
Yeah. And how many of these mock interviews have you done so far?
Okay, I've actually done one with you. My very first one was with you, I think,
Oh,
and I think this is my eighth. Okay.
okay. So looking at our feedback from last time, I mentioned that it looks like the main thing was to discuss the algorithm and
Right.
make sure it works and make sure that's optimal, and then code only after doing that.
Yes. Yes, I remember that.
Yep. All right. This time we're doing just a generic data structures and algorithms interview. So you haven't picked any specific topic to focus on here.
Yes.
Are you ready to get started?
Sure. Let's do it.
Okay. So I want to spend about 35 minutes working on a coding question, and then we can discuss solutions and feedback in the remaining time.
Okay.
All right. So for this problem, suppose we're given as an input a bunch of names of files. So I'll give you an example.
Okay.
This is a bunch of files. Well, they're absolute passive files, right?
Okay.
And these files encode a directory structure, which I'd like you to print to the screen as follows. So the format here, we show that web app is a top level directory. And based on looking at these three files, you can see that it has a subdirectory called assets. So I want to print that inside with some indentation, like you would see in an IDE. And then based on these first two files, you can see that assets contains a directory called HTML, and that contains contents A and B.html.
Okay.
And these are all printed in this nice form where the parents show you what their children are.
All right.
Yeah. So I'd like you to just print this to the screen.
Okay.
Or to the output, or whatever that is.
So just my initial thought on this is to build a tree to store all of the directories and the files. So for each directory in files, we parse it so we can get all the directories split by slash /. Okay, so and then we need to probably create a tree. So this is the create the tree part. Create
Yep.
tree. So the goal here is each node contains a directory or file. It's gonna be a file if it's a leaf node.
Right.
Parse it, so we can get all the directories and then insert each directory. I'm thinking it's similar to a prefix tree when we insert. Is that the correct term? Prefix tree or try?
Yeah.
So we keep inserting the directory if it right, if it exists, insert directory if it doesn't exist. So, exist if it does, while it
Right.
exists, just follow the path until it doesn't. So we can insert and insert.
Yeah.
So that's the first part, I think. So that would take number of files. So parsing it would take O of, let's say, n here is the number of files. Just n is not length of files. And but we have to parse it. So the number of characters here matter. But by splitting it, we only do one pass each for each file. So let's just say that this is the max maximum length of a file. A file. But
Yeah,
we
I think that
also
sounds about right.
okay, so that's the first part. The second part now that we have that tree, is to, I'm thinking we should just traverse it in is this right? So if we have this web app assets HTML, it looks like pre-order.
Yep.
In pre-order. And traversing it in pre-order, so this is DFS pre-order, would take O of the number of the number of nodes, but the number of directories. Can I just say that just the number of directories? Or are you looking to be more specific?
Yeah, I think that's fine. So that's the number of nodes in the tree, right?
Yes.
Okay, yep.
Nodes was does it are we satisfied with this solution?
Well, how do you do the printing?
Okay, sorry. So while we traverse it in pre-order, so since it's pre-order, we print it while we visit it. So we print while we visit the directory print dot the directory. But there are indentations, and it looks like the
Yes,
indentation is related to the level.
right.
So there's no indentation here since this is the root.
Yep, that's
This
right.
is okay. So print indentation times how do I word this? Times the level, the level.
Yep.
Before printing this. So I'm
Right.
thinking that that will work for printing. Yeah. So if we print, yeah, I think this would work. What do you think?
So how do you know which level you're at?
Yeah, so we need to pass while we visit directory. So while we can so while traversing, we can pass the level as a parameter, adding one each time we decurs. So we start with 0, starting with 0.
Okay, yep.
Okay. Are we good with this?
Yeah, that's
Okay.
yeah.
Should I start now?
Yeah,
Start
let's
coding.
begin with the coding.
Okay. So let's create the tree. So for in apps, let's define the function print directories. Let's just call it that. We're given files. So for each file in files, split, we parse it. These are the DIRs. And we need to keep inserting it in the tree. Okay, so
Right.
we need to define the data structure.
Yep.
As let's just call it prefix. It's a good name for this directory tree. Okay. Okay, so what we need is what do we need in a try? Let me remember. If I remember correctly, a node is composed of a hash map.
Yep.
Let's call it map. And the values in the hash map. So this is it has to have a node so that it can point to the children, of course, directory tree node. So we initialize it with a map and the children, which is
Wait,
um
is the children something separate from the map?
uh, yeah, you're right. Actually, yeah, the values in the map are the children.
Ah, yes.
Okay, so I'm so it has to have a I'm trying to think because if this is so this already contains the children, how are we
Yep.
going to place the children of that? Uh,
So how would it work in a try?
Yeah, I'm trying to remember how. So we have a hash map, and then that hash map should refer to another hash map. So it's like nested hash maps. That's what I'm thinking.
Well, what's wrong with just having the map?
Yeah, maybe I'm overcomplicating, I think. So okay, let's just try it for now.
Yep.
Having a map. So if you want to insert uh a set of directories. So this is a list of directories should get here. So okay, so while did we while it exists, just follow the path. Okay. So for the ours, we check if TIR in so we have a current map that we're currently looking. If which is the root map, if TIR is in current map, current map equals current map. So we just go to so we're going here with this path. Just follow the path until it doesn't exist.
Yep.
Else we insert it in the map. Okay, so
Hold on, is this
map,
is this a keyword? It looks like it's highlighted differently.
oh, this one?
Well, yeah, we just try it out. What is this?
Oh, okay. I'll
Okay,
just,
yeah, that's some function.
oh, sorry. Okay. In the IRs, okay. Per map equals, so we insert it if it doesn't exist.
Right.
Directory. Okay, so for each,
Is this what we're inserting?
the directory.
So the key and value are both the same?
Okay, so this should be a hash map itself. Directory an empty hash map, since it's a newly inserted
Oh,
node. Do you still have questions here?
so your entire try only has one node.
Try has only one node. I'm thinking the try is just have one hash map, but it's a nested hash map.
Oh, okay. I see. But
So
then this,
so yes,
what you're calling the node is actually the entire try, not just one individual part of
yes,
it.
I guess.
Okay, I see.
Oh, okay. Yes, thank you for clearing it up. I guess that's the direction I'm heading, since that's the one I'm remembering right now.
Right.
It's a directory tree. Okay, so here, let's go back here a bit. It's not a node. It's the level of nesting. Sorry. No, nodes. Now that you're mentioning that it's not a node, how can we now?
Oh, yeah.
Traversity pre-order. Maybe we can do it iteratively and just use a stack instead of the normal recursive way. I'm thinking we can still do this. Are we fine with that?
Still do the DFS with this format.
Yes.
Okay, yeah.
Just do it manually. I mean, iteratively, and maintain the stack ourselves. Maybe I should just finish this first. Do you agree?
Okay.
Or
Finish what?
this part first.
Oh, okay.
So for each directory, let's split, we insert it in the directory tree. So we have to initialize. Let's call it T3. Is it even a tree? Try. Okay, so we keep inserting. Actually, so since we're inserting the DIRs, we should actually do this here. Okay, DIR. Okay, so for direct split. Oops, disappeared. So the list of directories is going to be passed inside here. Delete that, insert. Okay, so yeah, I think this this combined with the data structure performs this part. Do you agree?
Can you repeat that?
So I think this small code here already performs the creation of the try.
Okay, sure.
So now we need to traverse it. So process try in reorder.
Right.
Okay, so start first with let me remember now how we do pre-order in tries. So I think we need a stack.
Why is that? Well, your pseudocode was saying you would use recursion, so now you're doing something different. Why is that?
Yes, I actually assessing if I'm able to do it with recursion versus doing it iteratively. But okay, I'll try it with recursion.
Okay.
So let's just do a helper function here. So this is the current map.
Yep.
So the goal here is to call the helper function with R3 and then return. So inside it, we must do the printing. Okay, so since it's pre-ordered, let's print it immediately for each value. Oops. For each directory that's in our current map, just print. Oops, we need also the level. Print implementation tree level. Okay.
Yep.
So the level, we start with 0. So for each directory, we print the directory. Oops. We print the level, the number of was it like how many was this? 1, 2. 1, 2 times level plus this hyphens plus the directory. But since we're doing pre-order, we have to call. So while while it has a value, because if it's a leaf node, it's an empty. Oh, it's not going to be printed anyway. So let's just call keep calling the children in. I think we can Yeah, this looks like DFS. And the level. Increment the level. I think, yeah, so this is pretty much DFS, but
Yep.
just working in hash maps, not the regular nodes.
Right.
Yeah, I think we got it. Should we try?
Or should we, what?
Sorry,
You said, should we what?
should we try having a run through?
Yeah, some testing would be good.
Okay, so let's try, let's at least test the creation of the tree first. So, okay, what's the best? Just copy paste this so that I don't keep scrolling. Okay, so we go to the first, we iterate on the files.
Yep.
So we have this as the first file. We split so web app assets HTML. We attempt to insert this. So current map. So this is the current map. If it's not in the directory, so becomes this. Oh, we should actually, if it's not yet in the, if we keep inserting the directory, we should actually, wait, current map directory.
Yes, something is missing there.
Yes, the current map should now be the current map directory.
Yep.
Okay, so we come now to asset. This become a nested HTML. Maybe you can give me some tips how to run through effectively with this later.
Yep, I think that's a good way to represent it.
H.html. Oops, these are strings.
Yep, they are.
ML.
Oh.
Okay, that's the first one. So the second one, these are already created. So it will just, actually we can just take it out, right? Because
Yep,
it's
we
both.
can definitely do that.
So let's just invert this. If not, let's just put it here.
Not in,
It's
right?
more. Yes,
Yeah.
nothing. Okay, so we will now insert B. So the same happens here with the first one. Since the first one already inserted all of the parent directories, so web app asset HTML, and then insert B.
Yep.
The next one, web app assets, is already inserted. We create for JS web app asset HTML. I think this is the right one. JS. Wait, This is for web app. This is for asset. This is for okay. JS. Then we insert c.js. Next one, web app, already there, index.html.
Yep.
So it's in the level of asset. Okay. Okay, so this is our try. Now we traverse it in level order. So yeah, maybe I can arrange it like this so that I can visualize the levels. Oops. HTML. JS is in the level of, okay. Index is in the level of asset. Okay, just to make it easier to visualize. So we start with the root. We it only has web app, so it prints. This is the printed. See, prints. So it has 0. We start with 0 level. So it prints 0 spaces, then this, then web app. As web app. Oops. You know what? Let's just print it like this.
Right.
So so it access web app. It now has the curl map now has asset and index.html. But asset is first. So asset.
Okay.
We should
What
I
happens on line 56 at the very beginning?
it enumerates all of the values, all of the directories in the current level.
What is cur map?
The curl map is the nested hash map.
Is that
So
what you're passing
our-
in?
Yes. So our try is a nested hash map, right? Oops. Oh, sorry. You're right. That map.
Yep.
Yep,
Okay.
thank you.
Yeah, we're out of time, but no, this looks mostly good. You know, there's one other bug, which is that when you split a string based on slash, the first element is going to be an empty string, which is what comes before the very first slash. Right? So you need to skip that when doing the insertion in your try.
Okay.
Other than that, I think that's good.
Yeah, bug. First value is space.
Well,
So
not even a
address
space,
this.
but empty.
Is empty. Okay.
Right.
So address this.
Okay.
Uh,
Yeah, that's
okay, I
really all
didn't-
that's missing, and this extra parentheses here.
Oops. Oh yes. Oh. Oh, okay.
Right. Right, cool. Yeah, so you pretty much found the optimal solution and coded it mostly correctly. I guess one thing I could point out is that the way you're using the try, since you're just storing maps instead of other try nodes, then yes, you don't need the class, right? So all you're really doing is using the class to store a map, and then you never interact with the class itself.
Yes. So the reason I'm if I may know, the reason I abstracted it in a class is that when if ever I need to go back, I just I just have a visual reference. Oh, this is the class. I can just
Oh, okay.
it's just for convenience for me, I guess. I
Yeah, I
can
think
just
having
refer
it
to it.
right, separating it out definitely makes the logic easier to follow. But I do want to point out that, you know, it's not really needed in Python. It's needed in other languages since you have to declare what type the map has. And so you can't have nested maps in other languages unless you define a class for the try node.
Okay.
Well, in statically typed languages. In Python, I guess you don't really need that. So directory tree, all I did was store a map. But I didn't really do anything else for you. But I can see that, you know, there is some benefit to having it separated out so that it's not, the code isn't mixed in with the, you know, the rest of the code. Yeah, I think that went pretty well. I suppose one thing that could go better is that the complexity analysis on line 28 isn't accurate. So,
Oh,
with directories, well,
right.
the TFS will traverse every node, not just the directories. And the amount of printing it does depends on the length of the strings.
Oh,
So it's
I missed
also,
that.
yeah, so it's also still n times a from creating the tree.
Right. Yes, but at least I got it here. So
Yep.
the
Yeah.
overall is still this. But yeah, you're right. This is n times a.
Right. Maybe you made that mistake because you analyzed the complexity before deciding what goes into the helper function. I imagine. So remember, at the time, you had not put in this pseudocode about printing, right? So maybe that misleads you to, you know, not analyzing the complexity involved in that printing.
Yes, yeah, you're right. This actually came later, so I
Right.
didn't go back.
Yep. So I guess it would be better to figure out the details and then use that to get the complexity analysis. If you do the complexity analysis too early, then you're not taking into account the cost of things that you add later.
Right. Yeah, so the thing I noticed that I have to upfront tell that the planned time complexities before coding. That's what I noticed with my mock interviews. So I guess I am trying to do it upfront instead of
Right.
maybe maybe I should just, you know, after coding go back to it and review the sort of planned complexities if it still matches.
Say no, not after coding, after you're done with the pseudocode. So when you're talking about creating the tree, that part was done
Okay.
well, right? Because you have n times a, right? You wrote that after you figured out the details on lines 24 to 26. Right? But in the helper function, you did the complexity analysis before you wrote lines 30 and 31. Right? So at that point, you didn't know that there's also this times a needed to print the characters.
Okay. All right. So I have to flesh it out first.
Right. You can't analyze how long something takes if you don't know exactly what that something is yet.
Right. Yes.
Which you did well in the creating tree part.
Okay. Good. So I'm just wondering, okay, what's the difficulty of this problem?
I'll call it medium.
Oh, okay.
Yeah, the code is pretty short, so I don't think it can be hard. And it's also, it doesn't use any like obscure data structures.
Right. Is that good? Are you going to ask another follow-up question, or?
Nope, this is long enough that it takes the whole interview.
Uh, because I think in Meta they ask like two mediums, and I'm wondering um because they ask you if you've already solved the problem or seen the problem, right?
Mhm.
So I'm thinking you can only solve something like this, two problems in a 45-minute interview if you've already seen it. I mean, am I am I not am I nuts to think that? But then
Uh,
they want you to be honest with it.
yeah, I think they'll ask shorter questions or easier questions.
Okay.
So this one, even though the code is pretty short, I think the testing takes some non-trivial
Yes.
amount of effort, right? Since you have to draw the tree and then you have to show the traversal, right? And then drawing the tree is probably takes longer than the testing for other questions, probably.
Yes. Right.
Yep.
So do you have any tips for that? Do you have to lie or do you have to act that you don't know the in those situations? Would you rather, be honest and, I've already seen that, or, just act like, what do you think?
Well, I think it really depends on how well you can. Well, do you think the interviewer will figure out that you've seen it before?
Oh, uh, do you
Uh,
have any insight on that as an interviewer? Uh,
well, as an interviewer, I make up my own questions, so I already know that the candidate has never seen the question before, right?
oh,
So I don't have to worry
I
about
see.
it.
Okay.
Probably, yeah, Meta. The interviewers, since they're asking common questions, then they probably get a bunch of candidates who have already seen it before. So I
Yeah,
wouldn't
that's
really
right.
know how they think about it.
Yeah. So this time, so the first time I interviewed with you, okay, I didn't make the cut. How about this time?
Uh, yeah, this looks a lot better than before.
Okay, a lot better, but still didn't make it.
I think yeah, I think this is good enough actually. So you finished a reasonably challenging problem. I caught some bugs for you, but then you also caught some yourself by testing. I think the bugs at the end were minor enough. The empty string and not passing the try instead of the map. Right? I think they're minor enough to be overlooked.
Yes. So I'm thinking if on the empty string part, so I think it will still work because so our current uh the current the root hash map will only contain the empty
Uh,
directory.
right, but then so your levels will all be off by one. So you'll have
Oh, that's
extra
right.
two spaces at the start of everything.
Oh, okay, you're right. You're
Yeah, so
right.
that just makes it makes a difference slightly
Yep.
there. Yeah. So I think this empty string issue is subtle enough that probably a live interviewers won't even notice it. Uh,
Oh, I have a question. Do you secretly run the code? The
Generally, no.
generally?
Sometimes, so there are rare cases where the interviewer doesn't know whether the solution works.
Oh,
So, if the interviewer doesn't have much experience with a question, the candidate might come up with a new solution that the interviewer is unfamiliar with. And sometimes, if the solution is complicated enough, it's hard for the interviewer to tell just from looking at it whether it works.
oh,
But
I
then,
see.
even then, I think the interviewer would only run it if the syntax looks correct. If it's if the syntax is too much like pseudocode and it's not easy to just fix all the syntax issues, then that's probably too much work to try to run it.
Right.
So I don't think I've ever actually run the code myself for a real interview. I can usually just tell by looking at it. There's, I want to say, one mock interview out of the many hundreds that I've done where the solution was unique enough that I didn't know it before. And I was also complicated enough that I couldn't tell just by looking at it whether it worked. So I spent about an hour running the code to confirm that yes, it does actually work after fixing the syntax errors.
Oh, okay. So that's why I was having during my last mock interview, I had this feeling that my interviewer is running it in the background. The way he was, he was commenting on, my progress.
Well, there's a lot of questions where you also just can't run the code since you use functions that don't exist or you use classes that don't exist. In this question, the directory try class is simple enough that you can just write it, but there's other questions where whatever class you use, it's long enough that you wouldn't really have time to write it. Like for example, a union find question. Union find, it takes more code than what you've written here for the directory try.
Right.
And probably any kind of binary search tree question.
Do you have instances where how the applicant looked or how the applicant his aura or her aura affected the result of your interview of the results, not just the coding part?
I mean, how the applicant looks.
Yes, how they presented themselves.
I usually don't even look at the camera in the interview so in a real interview, I have to take notes and I also have to look at the code, the shared code link, right? So that means there's really not much attention I can pay to what's happening on the applicant's camera.
I see. Okay.
Yeah, I don't really care if they're like how they dress or what's in their background.
Oh, I see. But how I presented myself earlier and during the rounds. What do you think? Do you have any? Oh, you just said that you're not focus on that. So, but if you have some little notes, do you have any on how to present?
Nope, I don't have any.
Oh, all right, fair enough. Okay. Okay, thank you so much.
Yeah. Any last questions?
Yeah, that's pretty much it for me. Thank you so much.
Right.
You have a good day.
All right, you too. I look forward to seeing your resume.